But good morning. I'm glad to have all of you with us today. I'm glad the weather kind of cooperated with us. At least it's not snowing. But we're in for a treat. We have Mike Warnke here from the Georgia Department of Education to share with you a lot of insight about where we're moving, how we're moving forward with our new standards. So I'm not going to spend time talking to you. I'll turn it over to him.
Thank you. Thank you so much. Good Friday morning. That's good. Yes, I at least got some smiles from that. So I'm Mike Warnke. I'm the elementary math specialist at the DOE, and that sounds like I have a lot of power. I actually have none. I'm really just an educator that happens to work actually from home, but in Atlanta technically. So today we got a couple of things I want to talk to you about. One is, first of all, the new standards, right? Kind of give you an overview of some of the resources that we have, and we'll spend probably an hour or so on that, and then we're going to dive into some mathematical modeling and talk about what that is, and then we'll go to lunch, and then we got some other things planned for you this afternoon. So again, I'm Mike Warnke. So let me see who's here. So where are my kindergarten teachers? There's, that usually doesn't happen until first grade raises their hands, but I appreciate your enthusiasm. That's great. How about first grade? Yeah, I knew they wouldn't let you, they wouldn't get away with that. Okay, so how about second? Yeah, they're like, all right, let's get to work here. We got stuff to do. Any coaches out there today? Oh yeah, that's what you get from coaches. Yay. Interventionists, we got any of them out there? I guess we're all interventionists, right? You should all raise your hand. How about administrators? I think they're out there, they just don't want to raise their hands. And they're certainly not going to go, woohoo! All right. Okay, so again, I'm Mike Warnke. Let's do something. Let's see how much you know about the new standards already. We're gonna do something. So everybody, just kind of stand up. You don't have to move anywhere. Just kind of stand up where you're at. and I'm going to ask you a couple of questions about the standards. And I'd like you to, if you're not sure about the answer, you can sit back down. We're going to do this a couple of times, so we're going to get up and down a few times. So I'll ask you a couple of questions, and I just want you to see what you know. Okay. So first question is, what is the name of the new standards? What are they called? And if you think you know, you can stay standing. If you're not quite sure, you can sit down. What is the name? What are they called? What are the new standards called? Oh, okay, good. We got two people. Three people. Okay. One person. Yeah, take a guess. Yeah, it's right there. Yeah, it's yeah. Use your clues, right? Georgia's K-12 mathematics standards. Yeah, they're not the new Georgia Standards of Excellence. They're not Georgia's amazing math standards. That would be GAMS, and that could cause some issues if we talked about those. So yeah, we're Georgia's K-12 mathematics standards, and it's a mouthful. We're just going to have to kind of deal with that. No acronyms for these standards. So let's stand back up. Let's try another one. And let's take a risk today, okay? It's a safe space. I mean, this is a safe space. We're in a church, right? So it can't be too bad, right? So just take a chance. Even if you think you're wrong, a safe space. We're all here to learn. How many standards are there in every grade level and course K-12? How many standards do you think? Oh, come on, take a risk. Take a chance. All right. Okay, I'm going to call on someone. Take a chance. No, come on, take a chance. What do you think? 15? 15? There's actually lower than that. Would you like to take a chance? You know it's lower than 15. I'm sorry? Oh, yeah, okay. You said 10? Yes, it's 10. 10 or few. In K-5, in every grade level, there are less than 10 standards. In high school and middle school, there's 10 or fewer. The course with the most standards is high school geometry. So just be thankful you don't teach high school geometry. You don't have to teach that many standards. We'll talk a little bit more about that. And so you did pretty well with that. So, but I kind of get the sense that there's still a little unsuredness out there. So let's try this. We'll do something a little bit different. We're going to do something called a fist to 5. All right, so fist means that would be this, 0, right? 5 would be here, right? So fist means 0. That means like, what new standards? I didn't know we had new standards, you know? I think I came here for something else today. So that would be that. And then 5 means, oh, we got new standards. Yeah, I could do this tomorrow. So just give me a fist to 5. And if you're using 1, just be wary of the finger you're using. All right? Just hold up your hand, fist to 5, whatever you think. Oh, nice. Good. 2s and 3s, love it. No 1s. And when I did this with the 3-5 people, you could tell because they were trying to do half fingers, you know, because they do fractions in 3-5, right? Okay, so that's great. So I didn't see any 1s, I didn't see any 0s. We're all like 2s, 3s, and 4s, and that's great. So hopefully by the end of this training this morning and your time to talk in the afternoon, hopefully we'll have a little bit of a growth, and maybe if you're a 2, you're a 3, maybe if you're a 3, you're a 4, and so on. So let's go to the next slide if we could. All right, so this is the team that I work with. Actually, there's one more person who just started yesterday, and her name is Yenna Perret, and she is the new, what is she? She is the new ESOL math person on our team. She's still got the deer in headlights because she just started yesterday. So we're waiting to get a picture that she's not a deer in the headlights. But she just started yesterday. Dr. Snell up in the upper right-hand corner, she is our leader. She's the math program manager for the state, and the rest of us up there, the 2 other people at the top, Carla and Kenneth, are the secondary people. They do what I do, but just for secondary. And then Janice is the content integration specialist. And if you ever have a chance to hear any of these people talk about anything, any trainings, I would highly recommend that you get a chance to, if you get a chance to go see them. I learn something from them every time I hear them talk. Now, a couple of things I want you to remember. If you don't remember anything else from today, and I hope you do, but if you don't, there are some websites off to the right here. The very first one, GaDOE.org/mathematics, that is where you're going to find every resource for the new standards. Every single resource that we put out is uploaded to that site. So if you don't remember anything else, that's where you need to go. The second one is community. If you're not a member of the Georgia community, community.gadoe.org. It's a great place to just free. It was created at the state level as a place for teachers to go interact, kind of like a social media just for Georgia teachers. So as you're engaging with the new standards, as you're learning about the new standards, and you're like, what does this mean? You can go on there and post it, and other teachers who teach the same thing that you do can respond and say, here's how I did it, and you can do the same thing. It's a nice place to just go and talk about the new standards and teaching in general. We'll talk about the other ones as we go through. So let's go to the next slide. Okay, so just really briefly, as you're engaging in the new standards, as you begin to start looking at the new standards, note that there are progressions built into the standards, okay? There are resources like the progressions. There's guardrails that are built into the standards as well, like that tell you, here's how far you go as you teach this standard. You can certainly go further if your students are ready, but this is kind of the expectation for the grade level. So there's learning objectives and expectations that are built in as well. So was anyone here the last time we did a new standards sweep? Anybody out there? A couple of head nods? Yeah, a couple of you. Remember how great that was? Yeah, no, it wasn't that great, right? Because what did we have to do? What was that called? Crosswalks, and what was it? There was another thing we had to, what? Deconstruct. Yeah, we had to unpack. There it is. Yeah, how much fun is unpacking standards? I can't say here because it's a church, but it stinks, right? It's horrible, right? It's tedious, right? It was probably a good thing to do, but it wasn't. It really, when I did it, it didn't really. I don't think it really helped me. So, what the teams did that revised the standard, all the 200 plus teachers that revised these standards, they said, let's unpack it for the teachers, and that's what's been done. We'll show you what that looks like. Also, as you engage with these new standards, we want to make sure that you explore the embedded ways to help students master the fundamentals. How many times have we heard that over the past 10 years? Kids need to know their fundamentals. They need to know how numbers can be put together and taken apart. And they need to be able to do it fluently, right? We want a solid foundation in numeracy in K-5 so that when they get to 6-12, it's not an issue. And that is built into the standards as well. Also, to build relevant pathways to big ideas. So instead of teaching in 4th grade, I think currently there's 46 standards. I told you a little while ago, that's down to 10 or fewer than 10 in K-5. So we're looking at bigger ideas that we're teaching so that there's a natural way to start connecting ideas, mathematical ideas, to one another. And also the foundation of part-whole reasoning and flexible thinking, which ties back to that numeracy development, right? So when we talk about students being fluent in mathematics, right? That's a big word, right? Fluency. What does it mean to be fluent? What? Easily, yeah. Okay, I would agree with that. Quickly is not necessarily a fluency thing, because in reading, do we say if they're fluent, do they have to be quick? They have to have a nice pace, right? But they don't have to be quick. Only in math do we say fluency is quick. But I think you're right, it has to be easy to think about. So there's 3 ideas for fluency. Okay, one is flexibility, that's up there. So being flexible in the strategies that you can use. Or strategies that you kind of have in your back pocket to use. Flexibility, accuracy, right? We want kids to be accurate. So if you're fluent, you have to be accurate. And the other thing is efficiency, and I think that speaks to what you just said about being easy to think about. So flexible, they have to be flexible thinkers, they have to be accurate, and they have to be efficient. Flexible and accurate, everybody kind of understands those. What does it mean to be efficient? So here's what I want you to do. Talk to your elbow partner for 90 seconds. What does it mean to be efficient in mathematics? Go ahead, 90 seconds. What do you guys think? take it from your silence that 90 seconds is up. So that's where we'll go. What I heard from just a couple of people, but what does efficient mean, do you think? Somebody from this area. What did you talk about? Don't all jump out at me at once. I'm really good at wait time. Smarter, not harder. Oh, nice. Throwing out a nice little thing that we've heard forever, right? Smarter, not harder. So can you explain that a little bit? Yeah.
Trying to find the easiest or shortest path.
Oh, shortest path. That's really I think a nice way to put it. Anybody have anything to add to that? I think who was it over here? You guys said something. I don't remember. It was quickly, correctly, with ease. Right? And it's hard to get out of that. When we talk about fluency, it's hard to get out of the idea of quick, but we really need to, because what does quick mean? Does quick mean, 8 seconds? 4 seconds? 9, 10 seconds? So it's hard to put a time when we're talking about fluency. And when we do, then that says, oh, let's do some time tests to see if they're fluent. And those have been proven time and again not to work, or not to get us what we actually need with students. But everything outside with ease, I think you're spot on. So, but you said shortest path? I don't think I've ever heard that phrase before for this. I really like that. So I think you pretty much nailed it. So with ease and shortest path, I think those are two really good ways to think about efficiency. Another way I've heard doing this forever and talking about fluency with teachers for a long time is the least number of steps. So shortest path, least number of steps with ease. Those are kind of what we're talking about. So have you heard of number talks? Have you done some number talks before? So have you ever had, like when you first started number talks, this is what happened to me. I told kids, however you can do it, and I went about it the wrong way. And the kids started doing like 45 plus 23, let's say. And they said, well, first I broke the 45 into 40 plus 5, and then I took the 23 and that's 20 plus 3, and then I took the 3 and I made it 1 plus 1 plus 1, and I took the 5 and I had 1 plus 1 plus 1 plus 1 plus 1. And eventually they started putting things back together and they got back to 45 plus 23, and then they did something else and they got the answer. Now, they got the correct answer. Was it efficient? Absolutely not. They walked all the way around the room 5 times before they went out the exit door, right? But they got the right answer. And it took me a while to realize, I really need to focus on efficiency. And I really needed to talk to kids about what it meant to be efficient. And the goal was to be efficient. So once we had that conversation and we talked about it's the least number of steps or the shortest path or it's easy to think about, that's all we had to talk about with efficiency. Oh, that's what we're shooting for. The other thing with number talks is a lot of times, and maybe you've noticed this, I know it happened to me, is kids they do really well with the strategies in number talks, but when they solve problems, like in math class, they're solving the problems in the math class, they don't use those strategies. They do whatever other thing they're doing. So I had to be explicit with students, say, hey, you guys are doing some great strategies in the number talks. When we solve our problem today, I want you to try some of those strategies. Show me that you can use them. Really show yourselves that you can use them to solve problems. And that helps as well. So let's go into the next piece. All right, so as you engage with students now, we want to make sure that you're communicating that to students. So communicate that flexibility is what we're looking for. You might know one way to solve a problem, but maybe knowing 2 ways might be a really good thing to know too. Like, if you're adding 99 plus anything, there's a lot of different ways to think about it. Some are really efficient, right? Like I could think of 99 plus 35. Well, that's really close to 100 plus 35, right? And then take one away, 134. I didn't have to write anything down, right? That's an efficient way to solve 99 plus anything. So being flexible and knowing and letting kids know that it's okay to do a problem one way because of the numbers that are involved, and then a different set of numbers for the same operation, you can do a different strategy, and that's okay, right? So letting them know that. Focus on reasoning. Big piece of these standards is reasoning. Helping kids understand that knowing how and why things work in mathematics is a really good thing. Also, obviously, effective mathematics teaching practices, those are a big deal as well. We want to make sure we're using those. And then, I think we've gotten away from helping kids realize that learning math is fun. It's engaging. There's a lot of connections that can be made, and we need to get back to that so that we can help kids build a solid, deeper understanding of mathematics and realize that math is all around us. Leah, our supervisor at the DOE, says this all the time. Math is the language of the universe. We want to help kids understand the language of the universe so they can explain what's happening around them. All right, these are the big ideas. Take a minute, talk with your elbow partners. What do you notice and what do you wonder? 90 seconds. Okay, so what do you notice? I saw a lot of people talking and pointing. What's one thing that you noticed or wondered? Elementary is the foundation. What made you say that? Oh, yeah, nice. Yeah, you can kind of see how everything is fairly consistent all the way across, right? Nice. What else did you notice? Yeah. Oh, yeah. Reasoning is up there, like almost every one says reasoning, except for the first two, right? The mathematical practices, which actually reasoning is embedded in, right? And then mathematical modeling, which you need to be able to reason to do mathematical modeling. So reasoning is throughout. Great notice. Thank you for sharing that. What else do you notice? Or any questions that you might have? Yeah, that's kind of weird, isn't it? Yeah, I think you're kind of right there. Let me push you a little bit further. Okay, so measurement and data reasoning, there's two things going on there. There's measurement and there's data. So obviously, data reasoning is kind of new to K-5. Actually, I'm sorry, data and statistical reasoning is new to K-5. So the data is kind of tied in with that, all right? So that's something that it's going to continue in that little pinkish purple area. So we don't need to worry about that. But measurement, what do we do in measurement in kindergarten? Non-standard units, right? Right? We continue that in first grade, right? That's the same thing, it's not changing. We're still doing those things. It doesn't make sense to do standard units with kindergarten and first grade. By the time we get to second grade, we introduced those standard units and we begin to measure with those. Once we get done with that, third grade continues with that, but they also do, if anybody's taught third grade, they expand on the measurement ideas and they start measuring not just linearly. They start talking about area, right? Fourth grade builds on that and they continue with area with some weirder shapes. And then fifth grade takes that and expands on that and starts to talk about volume. Now that's geometric measurement. So those actually build into the geometric side. And that geometric and spatial reasoning, that measurement builds into that. They continue to certainly measure length, width, or length, weight, and mass, volume. But those are all built into the geometric side. So it doesn't end. It's still a thing. Any other thoughts? Nobody really wonders why there's two probability things? Probably because it doesn't pertain to you all, right? And it almost did. Like they were talking about bringing probability and making it a progression so that we'd actually start talking about probability really generally in elementary school. None of the elementary teams wanted to do that. I know it's just one more thing, right? So they decided not to. So it's currently taught in 7th grade and in high school geometry and beyond. It's just the way it turned out. And actually that's the way it is right now. They start in 7th grade, there's a big break, and then they do it in high school. Functional and graphical reasoning, that's actually built on another idea that you actually start teaching in kindergarten. Which one? Which big idea builds up to the functional and graphical reasoning, do you think? Which of those big ideas? What do you think if you had to guess? That's it? Patterning and algebraic reasoning, yeah. When you start teaching about patterns, you're teaching kids to think algebraically. What comes next? Make a prediction, right? What's the pattern? How can you identify that pattern? What's the rule to get to the next term in that pattern? That's teaching kids to think algebraically, looking for rules. So we're actually building that in kindergarten through 5th grade, 6th grade and 7th grade, and they started that in 8th. All right, let's go on to the next one if we could, please. So this is, don't know why this is here, I thought I changed it, but this is algebra. That's why there's an A there. And let's click one more time. This is the mathematical practice standard. Now, currently we have the standards for mathematical practice. There's 8 of them. There are still 8 mathematical practices, but we have one standard that kind of encompasses all of them. And that's really important. We want to make sure that we're helping kids think critically, to reason, like was said earlier, and then collaborate and seek and apply feedback. So whatever's going on in the classroom, that culture of the classroom has to be one as such, so that we're helping kids create goals and meet them, giving them feedback, and they're actually applying that feedback to improve. Let's go one more time. These are the content standards. So you can see how many content standards do they have? 10. How do you know it was 10? Did you count them all? Huh? There's a 10 at the bottom, right? Yeah, they're in order, right? And they're actually in order, in an order such that so that you could teach them in that order. Like our current standards, they're all over the place, right? You could actually teach the standards in this order. They were designed and written that way for every grade level and course. Now that doesn't mean that when you look at the curriculum maps, that you'll see them 1, 2, 3, 4, 5, 6, 7, 8, because sometimes things can be taught together. So you might see, like in second grade, you might actually see the data and statistical reasoning, which is usually further down, is taught in the beginning, because we want to start talking about data in the beginning of the year, and we're going to continue it throughout. So you may actually see some later numbers earlier than you would expect. You might expect them from looking at this. Let's go one more time. So this is the coding and naming. So the grade level comes first, the number comes first. The big idea abbreviation, FGR, what do you think that is? Which big idea was that? It's not an elementary one. I don't know why I got the high school one on here. Oh, there you go. Functional graphical, right, thank you for doing that. All right, and then so the number and the sequence. So that would be the 7th standard. It would probably be taught toward the end of the year, but again, it might be connected to another standard as well. All right, let's go to the next one. So this is 7th grade. Again, I'm not sure why those were changed, but so I apologize for that. Let's click again. We've got the standard. That is the expectation. That is the end of year expectation for this is 7th grade. This 7th grade, so the 7th grade student, that's the expectation. That's the standard. That's what they're going to be assessed on the milestones. That is it. Okay? The rest of it, let's click again. This is the coding for the expectations. Let's go one more time. These are the expectations. This is how the standards are unpacked already for you. So these kind of give some guidance. I talked about guardrails a little while ago. These are the guardrails for that standard. So here they're going to be talking about probability. This is the probability one. How far do they go with probability? Do they do compound probability? They do kind of the guardrails. The evidence of student learning gives even more guidance. Gives you some suggestions, some examples, some terminology perhaps, some strategies for teaching and learning, and age and developmentally appropriate, some fundamentals about what it means to teach this standard. All right, let's go to the next one. One more. Now for instructional purposes, this comes from grade 5 curriculum map. For instructional purposes, those learning objectives are not meant to be taught as a checklist. All right? They're meant to be clustered together. So those ideas that go together are taught together. Like comparing numbers, like counting and comparing. It kind of go together, right? Or writing numbers and identifying numbers and comparing numbers, they kind of go together. So you're going to see them taught a lot together. In 5th grade here, this is polygons. So this is geometry. And you can see there are 2 learning objectives that are put together along with another one from numerical reasoning that's in there. Those are all going to be taught within the same unit. All right? And ultimately, the blue, those are the standards. The standards for you all, for every grade level and course, are always in blue in every single document. It's the same shade of blue. I could tell you the hex code if you really wanted me to, because I've done this so much. But that is the end of year expectation in the blue. Let's go to the next slide, please. Oh, sorry, go ahead. All right, so here are some of the resources that we have so far. And these are some that you may know already, but let's go on to the next slide. All of these, this is everything that we have ready for you. You can click on it at georgiastandards.org/mathematics. All of these are ready for you right now. Let's go. I'm going to run through these really quickly. We also have some things coming soon. I'm going to get to these as we get toward the end of the slides. First thing I want you to pay attention to. In the standards document, you'd be in the K-8 document. All the standards for K-8 are in one document. You guys are at the very beginning of that document, so you don't have to go very far to get to your stuff. Not a lot of scrolling though, because you can click, there are links to get to your specific grade level. But one thing I do want you to look at is the essential instructional guidance section of the standards document. And that is at the very end of the K-5 section. It's on page like 112 or something like that. It's a really good place to start because it explains the mathematical practices, which you probably are familiar with because those haven't changed that much. The wording is the same as our current standards for mathematical practice. But there's also information about mathematical modeling, which we're going to talk about a little bit later this morning, and statistical reasoning. And remember when I started, and that second slide had our pictures on it and the websites that I talked about? And I said, if you don't remember anything else, remember this. I take that back. I want you to remember this instead. This is really, really important. A framework for statistical reasoning. Statistical reasoning is new to K-5. We've had measurement and data, but not a lot of statistical reasoning. And that was decided by the teachers on the teams that rewrote the standards. We needed to have a bigger push for statistical reasoning. And the reasoning is because, anybody been to the supermarket lately? Every time you buy something, what are they doing? Collecting our data, right? We need to have kids that understand that and can realize when their data is being used for their benefit and maybe not for their benefit. So in the framework for statistical reasoning, there is a section where it explains everything that you need to know about what you need to do to teach statistical reasoning for your kids. It's not in the standards part, it's here. So you get instructional support for how to teach statistical reasoning for your specific grade level, like in first grade. What graphs do I have to teach, right? Second grade, what graphs do I have to teach? What kind of data am I dealing with in kindergarten, right? And that is all answered only in this section. And again, it's around page 112, 113. Really, really important that you know that, because you're not going to know it just looking at the standard for data and statistical reasoning. It's just you're not going to see it. And also computational strategies. So every strategy for whole numbers is not listed here because it's impossible to list every strategy you could do for whole numbers for addition, subtraction, multiplication, division. You just can't do it. All right, there's just too many of them. But this provides a nice sampling of what some strategies are for each of those computations, like addition, subtraction, multiplication, division. So those are in the essential instructional guidance. I highly recommend that you take a look at those. The mathematical modeling framework, this is what I was talking about. We're going to dive into this a little bit more deeply, but this is what it looks like. We'll come back to this in a minute. This is the framework for statistical reasoning that I was talking about right after this. So as soon as you see this in the document, you scroll next page, you'll see kindergarten and first grade. If you scroll a page after that, you'll see the second grade. All of the instructional guidance for statistical reasoning is right under that in the standards document. All right, this is the two of them. Again, we're going to talk about this a little bit later in the modeling section, but just so you know, that's there. So take just a minute. This is the authenticity of mathematical modeling. I call it the continuum for mathematical modeling. Again, we're going to talk about this a little bit more, but just right now, if I gave you a sticker, a little sticker, not with your name on it, but if you had to put a sticker, where would you be on this mathematical modeling continuum? And just mentally place it on the continuum. Are you more toward procedural mathematics and isolation? And that means in isolation of context. So just procedural mathematics, just following the steps. Or are you more conceptual? No, I like to have my kids use manipulatives and things like that. That would be the second arrow. And then in the third and fourth arrows, we're talking about, the only problems I give my kids are contextual problems. So that's kind of more up toward the top. So where do you think you might be? Just mentally place that sticker up there. Nobody's going to know where you place yourself. I'm not going to ask you to reveal it. I just want you to kind of mentally get a picture of where you think you are. And if you're a coach, where would your school be? Where do you think your school as a whole might be? And if you are a hiding administrator, do the same thing. Where do you think your school is? All right? And we'll come back to this in a bit. All right, let's go to the next one. This is just really quick. Go to the next slide. This is there's a new policy. This doesn't apply to you. It doesn't apply to K-5 at all. But just in case you have your own children who might be in like middle school or high school math classes, the calculator policy is changing this year. And the reason it's changing this year is because there will be some field test items for the new standards on this year's test. So the calculator policy is changing for that reason. I don't want to run through that, but just kind of take note of that if you want. We have a thing called Suitcase, where the new standards are also listed in Suitcase, and the course numbers are there if that's something you need to know. But there's everything that you see in the standards document is also in Suitcase. There's a link for this on that website I told you about, and it may be easier to use the standards document in Suitcase because you don't have to scroll. You can just click on your grade level and all of your standards pop up. And you can copy it much easier from there. If you got to put it into a lesson plan or something, you can copy it from this a lot easier than you can from the PDF. And everything that's in, every single thing, even the examples and pictures and things that you see in the standards document are also in Suitcase. So you can use either one, it's up to you. Let's go to the next. The units, they've started to be released. Okay, so we have Unit 1 for every grade level and course. Unit 2s are being released, probably more Unit 2s are being released probably today. And then even Unit 3 we're trying to get done by the end of this month. So by the end of this month, hopefully you'll be able to have Units 1, 2, and 3 of your grade level and your grade level. So that's coming. We also have interdisciplinary units that are being developed as well, and those are being added, and you'll be able to access those as well. This is the instructional design. So you know what our current frameworks look like, right? Big document, about 200 pages. Love scrolling to get what you want, right? Isn't that awesome? Scrolling? I hate scrolling. It's awful. It's tedious. I don't like tedious. But we'll get to that in a minute. This is the instructional design. Every single learning plan in every grade level and course follows this design. If you're familiar with the 5E model, it's more of a science thing. We kind of stole from that and we took one away and made it 4. Okay? We've got, let's go to the next. Yep, there we are. So in the engage section, this is a research-based strategy to get kids hooked, get them engaged in the context and the content that they're learning. In explore, this is usually a hands-on activity where students are diving into the math content. They're really diving deeply to learn and really understand what's going on. In the apply section, this is where they take everything they've learned from the first 2 sections and begin to apply it to a mathematical modeling problem or a really rich contextual problem. And in the reflect, this could be a journal entry. It could be a ticket out the door. It could be just a question that you want kids to discuss and answer. There's just a lot of different things that reflect could be. In every single one of these, there's suggestions for synchronous learning, asynchronous learning, and unplugged offline, just in case we ever have a pandemic again. We hope that never happens, but those are there. We also have this, which is really nice. Interdisciplinary unit planning tool, which is already developed. Those, I think, were about to be released, but they had to run through them and scrub them just to make sure everything was right. So those are coming very, very soon. There's also this planning tool, so once you get them, you can say, hey, I like it, but let's see how this would work for our kids in our school, and you can kind of tweak it as well. All right. You all familiar with the parent letters? You ever send them home? Yeah? What do you think happens when they go home? Yeah. And why do you think that happens? It's too wordy, right? It's what, 3 pages or more sometimes? And it's just too wordy. So we talked to our design team at the DOE, and they said, no. Make it colorful and put it in chunks so they can read what they want when they need to read it. And this is what they came up with. Now, we provided the content, but they put it in these things, and you're only seeing the first of 2 pages, and that's it. And you send it home once, or you put it online once, and they can just read it whenever they want it.
So these aren't parent letter guidance, they're
No.
for the whole grade.
It's a whole year. This is an overview of what you're going to learn in first grade, second grade, third grade, kindergarten.
Are they in Spanish?
Yes, they are. They're in multiple languages. Yes. They are not available yet. This is just a snapshot of the first one. PL. The PL that we've got is, we're doing a lot, actually. Let's go to the next slide. First of all, we're doing these RISA things, and I've got 2 more for K5. And then I've done every RISA. That's a lot. That's a lot of days. But to get to all of the trainings, this is what we're doing. We're doing the RISA right now. You can go to gadoe.org/mathematics. So we are, you know where we are. So we're going to go to the next slide. We also have these things. So we've had virtual specialists this is our 3rd year. And they've gotten better every year. The first year we focused just on what are you teaching? What's new in the standards for K1 and 2? Last year we focused on how do we teach that stuff, or the new standards. And this year we're focusing on mathematical modeling. Again, we're going to talk about that today, but to learn more about your specific grade level, you can do these virtual professional learning sessions. They are recorded, and they are on Saturdays. I know. Saturday mornings from 9 to 10. I don't think they've gone a full hour yet. It's usually about 45 minutes. You don't have to go every Saturday, but if you could register for 1 or 2, because if we have people come to these, even if it's just 3 or 4 people, if we have people come to these, the recordings are easier to watch. Because there's some interaction between the presenters. The great thing about this is they're by grade band, so K1, 2, 3, 4, 5, 6, 7, and so on. But the better thing about this is all of the presenters, all the facilitators are planning together. So no matter what grade level you're watching, you're going to see the same thing, but only with the content that's appropriate for your grade level. It's not just like one thing. So it's really good. Okay, let's go to the next one. Also, anybody go to MathCon last couple years? Couple of head nods. I see some hands in the back. Yes. It's been virtual for the past 2 years. That may be why you haven't gone. This is our first year this year on July 11th through 13th. So save the date. We're going to do it live, face-to-face in Atlanta. We think at the World Congress Center. We didn't know that last time I was here. Last time I said we have no idea we're going to do it. Actually, last week I said we have no idea we're going to do it. But between then and now, we think we're going to do it at the Georgia World Congress Center in Atlanta. So if you're interested, we've got a lot of good plans for some fun stuff, but also to learn more about the standards, obviously, and really plan to implement them in the fall. Okay. We have professional learning videos. You know the videos that we have right now on georgiastandards.org? One for most standards, right? We've got one video for every standard. Now, every grade level and course has how many standards? 10. 10 times, well, through 8th grade is 9, that's 90. And then high school has like 1 billion courses, right? And there's one for each of those as well. So what it comes out to is about 190 videos that we did last year. They're being edited right now. This is the set that we did at GPB Studios. They created that for us, so every single video has that same background. And that guy, he really doesn't look like that. He looks kind of scary there. But I chalk that up to, you know what it was like when we first started teaching virtually, and then if somebody's computer would freeze up and it was never a flattering picture, right? This is what happened to him. Great guy. He's doing a high school video, but we had some people actually in this room who were doing these videos. So just be on the lookout for those. These are like 10-minute videos at best, right? And it's just the person in kindergarten. This is the standard for 1 NR1, and they read it and they say, this is what it means, and this is how you can teach it, and here's some further resources that you can use, and boom, done. So it's just a quick overview of the standard, but it's something that you can use as you get started to teach next year. So those are coming. We do have several in the pipeline, and hopefully will be released very shortly. Okay, all right, so what time do we have? Dang, that was fast. I've done this a few times, I guess. So I want to let's just take a quick break. So if you need to stand up and stretch or something, I heard some of that stuff before. Just wanted to get through that fairly quickly, but make sure you knew that there were some new resources coming out as well. And this next part is more, I think, a little bit more engaging, a little bit more fun for you, and you'll be able to get up and move around a little bit more. But let's go to the next slide if we could. So what I want to focus on in this next part of the morning is really help you understand what mathematical modeling is, but also to help you understand how do we get students to become good problem solvers. Right? Sometimes some kids are so set in their mind that they aren't good at math, or they aren't good problem solvers. And then again, it's focusing on what mathematical modeling is, what does it look like in like a K2 classroom, and going back to that mathematical modeling continuum, where I had you kind of mentally place that sticker. And then how do teachers get started with mathematical modeling? How can you get started with that in your own classrooms? All right, let's go on to the next one, please. So, can we go to the next slide? Yeah, so what, no. Don't get ahead of me. So what is mathematics? Just shout something out. What do you think mathematics is? It's got to be something. It's working with numbers. Okay, good. What else? Numbers. Okay, good. Reasoning. Oh, so you guys are paying attention. Okay. Reasoning. Yes. What else? Problem solving. Okay, good. What else? Numbers, reasoning, and problem solving. That's it. Nothing else. Geometry. There we go. I knew somebody'd say it. All right. What else? Shapes. Sure. Patterns. I'm sorry? Data. You're all thinking, what were those big ideas again? I can say all those? It's naked math problems. Is that what you said? Naked math problems. I suppose some people think it is. All right. Okay. So what we did was we asked a group of students what math is. This is what we got. So now, what you all said, now granted you were primed in the first part of the morning, you said it was numbers, it was reasoning, it was problem solving, and I agree with all of those. But why aren't kids saying the same thing? I mean, when I first saw this, after the kids did it, when I first saw this, there was one of those just jumped out at me. Which one? Well, boring was the second one for me. Hard, because it's kind of sticking out on the upper left-hand side. It just jumped right out at me. So why are kids saying hard and boring, a class, instead of saying, like what you said, like problem solving, it's reasoning, it's numbers, it's geometry, it's data? Why is it so different? What do you think? Say again? They're not learning math for understanding. Unfortunately, they're learning it as a set of rules to follow, right? It's very procedural, right? So they're learning it in a way that they're not seeing the relevance, they're not seeing the connections. So when kids are doing, or when they're learning mathematics, they think, let's go to the next slide. This is what they are. I know, right? We don't want kids to see math as this. I don't. I mean, that's sad that kids think of math in this way. So how do we change that? How do we help kids see math the way, and describe math the way you all described it just a minute ago? Let's go to the next slide. We've got to help kids see mathematics and view mathematics as something that's, and there's 4 clicks here, that's useful, that's beautiful, meaningful, and that it makes sense. Because math is all of those things. Now, some people argue, well, math is beautiful, it's just numbers and shapes and things. Yeah, it is. Like, have you ever, and I'm sure this is the case, have you ever been in a math class where you had to solve a problem and you had no idea what you were doing? Anyone? Really? I'm the only one. Okay, good, thank you. Yeah. But then you figured something out and you got done with it and you saw the work that you did to get to it, to get to the solution, and you're like, dang, that's pretty cool. You know, what I just did is pretty cool. That's pretty neat. And some people describe that as beautiful, and I would be one of those people. Now, not all kids have to say, oh, math is beautiful, but this, if we can do this, let's go to the next slide. That would help us get kids from here, and don't go yet, but on the next slide, I want you to focus specifically on the middle image on the next slide. Okay, go ahead. I want kids to see math as this. See that little girl in the middle, right? Oh, that's math? Give me more of that, right? And we can do this, right? This is not impossible. We can change the way math is viewed by people, not just kids, but adults, the media, the entertainment industry. We can change it, but we've got to start somewhere. And we've got to start by helping kids realize that math is beautiful, it's meaningful, it makes sense. Because when it makes sense, our job to engage kids is a lot easier, right? If you're engaged in something, if something makes sense, it's easier to engage you in something, right? If something doesn't make sense, you're just like, I don't want to do that, right? But we need to help kids see that math makes sense so that they go like that girl in the middle. All right, let's go to the next one. Okay, here's how we do it. We help kids understand the 8 mathematical practices and engage in them daily. Because what's that first one? Make sense of problems and persevere in solving them. Make sense. It's the first one. It's one of the most important ones we have. But also we don't want to forget that standard, that blue, that's the standard. We want to make sure that kids are meeting that goal. Now, in order to meet that goal or get to that standard, they have to engage in those 8 practices. Let's go to, the next slide. So how do we do that? Let's go to the first. All right. So we have to empower them. It's all we got to do. We got to help kids realize that they can do it. Help them set goals, and then help them achieve those goals. Support them as they achieve those goals. help them by showing us our own attitude about mathematics. Even if secretly you hate mathematics, please don't tell me if you do. But even if you secretly don't like it or it scares you, we can't show that to kids. We've got to show them math is so cool. Math is such a neat subject. Look at what we can learn. Let's try to see what we can make connections with, to what you already know. Celebrate their ideas, even if they're wrong. Kid comes up to you in first grade, second grade, says 2 + 2 is 5. We all know it's not right? But accept the idea. Let's talk about that. What makes you think that 2 + 2 is 5? Even if they say 2 + 2 is 4, what makes you think 2 + 2 is 4? No matter what they say, we've got the same response. It's like, no, that's wrong. Well, that kind of pushes them back. Let's talk about that. And then celebrate their successes, support them when they need it, and then obviously we want to expect that great performance, high performance from all students. All right, let's go to the next one. I don't know why that's in there twice. Let's go to the next one. Okay, so we're going to come back to this, but I want you to talk to your elbow partners for just a minute. No, 90 seconds. I want you to talk. Why do you think I would put these 4 images up here to talk about mathematical modeling? What's so special about these 4 images? Take 90 seconds, talk to your partner. Go.
There's like different choices.
What's that?
I don't understand it.
The Amazon one? Oh, we'll get to it. We'll get to it. They make you happy? Choices. Oh, that's what they said. Everybody I've talked to, it's like they're all telepathically sending it to each other. Yeah, okay, cool. Anything else?
On the front, says how it is. Well, then all that is
Data, oh, that's interesting.
that there's
What about that?
no, it says 70 calories per cup. Well, the serving size is 1 bag, and the bag is more than
Thanks. So data is related to mathematical modeling. Okay, so I heard some, actually a lot of the same things from everybody I talked to. So let's have a couple of people, maybe like right here. What did you guys talk about? Why these images? What's so special about these things? Yeah, I think everybody, even kindergartners, probably heard of most of these things, right? Maybe not eHarmony, but if I was doing this with kids, that one would not be up here. That's just opening the door that I don't want to open, right? Okay, yeah, so they're familiar. Now, I'm not going to say yay or nay to any of the responses because we're going to come back to this later, okay? But I just want to hear what some of you are thinking. What would you guys talk about in the back? They make you happy. Well, you know, yeah. Lots of choices, yeah. Yeah, based on interests, right? I guess eHarmony hopes you be happy, right? All right, okay, nice. Thank you again. No yay or nay. I'm just kind of wondering what you're thinking. How about this group over here? Maybe somebody in the back. I didn't get to talk to you guys. I'm sorry? Probability. Can you talk a little bit more about that? Oh, okay. So you've already got a task kind of planned out what to do with it. Nice. Okay. Again, no yays or nays. Just we're going to talk about these a little bit later. And somebody from this side group here. Anybody? Oh, yeah. Go ahead. You're good. Dang, I got nothing else to say but that. Nobody has put that much thought into this. But we got it on. Did you get that? Record that? Because that was a really cool answer. All right. So again, we're going to come back to this, but I thank you. We'll talk a little bit more about why I chose these specific things. And I heard somebody said this. Actually, many of you said like choices. There's a lot of different choices, right? So I appreciate you guys engaging in that with me. We will come back to this in a little bit. Let's go to the next slide. Okay, so this I showed you earlier. This is the mathematical modeling framework. This is for K-12. This is not different for different grade levels. This is the entire cycle for mathematical modeling. Let's go to the next one. I think it's a little bit, yes, this is what I wanted to show. So this gives a little bit more information about what mathematical modeling is. So I want you to take notice that, first of all, it is a cycle, and the arrows go both ways. So a lot of times when I show this, teachers say, well, where do we start? It doesn't seem like there's a starting point. Well, there isn't really, but generally speaking, we'd probably start at the top in the red little rectangular, square, round thing. Because that's where there's a situation that's been presented to students, or a problem that's been presented to students, and that's when they make sense of the problem. That's that mathematical practice number one. And then they might even start thinking about, what do I need to solve this? And this is why I was so excited when some of you said choices. There's a lot of choices in that previous slide. Because when students move to that next orange rectangle there, they're beginning to use the language and tools and structures of math. So they're decontextualizing the problem and trying to put mathematics into it. So we're really taking the math out. They're gathering information, they're making assumptions or choices about what needs to be used. And then they're defining variables. Now don't freak out on me, all right? Because the last time many of you probably heard defined variable was probably in high school algebra, right? Did you have that same teacher that I had? You got to define your variable. And it was like this: let x equal. And then you had to make a statement what x equaled. That's not what we're talking about here. Defining variables in K-5 is defining the important information that you've got to use. What are those things we really need to think about and consider to solve the problem? Then students solve problems using mathematics. They use representations and strategies and methods, and they solve the problem and obtain that mathematical solution. Then they move on and they put it back into the context to see if it makes sense. So whatever they got, their math that they got, they put it back in to see if it makes sense in the context. If it does, then they can continue to develop it and interpret that solution as it's been created. Then they continue on, they evaluate their model, they interpret the solutions, they share their solutions. So like this group, they solve their mathematical modeling problem. You guys solve the same problem, you use two different models. You guys considered some information that these guys didn't consider, but they also considered some information that you didn't consider. And then you come up with a solution. You compare the models and see, we didn't consider that, but maybe we could go back, and that's why those arrows are there. They can go back, consider your information, or you can consider theirs and adjust your models to make them a little bit more accurate. Now notice they got two different solutions to a problem using two different models. That's weird, right? In math, you're supposed to have one answer, right? Well, that's not the way the world works, right? The world doesn't have an answer key, right? When mathematicians who work with the FBI, remember that show Numbers? Yeah. I can't remember the guy's name in there, the mathematician, but he said he was always creating mathematical models for new situations for the FBI to solve the problem. And he said, I'm pretty sure, he'd say something like this in every episode, I'm pretty sure that the next target will be here, because he defined the variables and made everything happen, worked out, and it worked out fine. But he was going on the assumption that we need to help kids realize that the world doesn't have an answer key. There's no answer key out there. You know, when you solve a problem, you got to do the best you can with what you got. So that's what that means. And then more questions. So the great thing about mathematical modeling problems is when kids are done, they usually they're so engaged in the process that by the end, they're like, what if we do this? Or what if we do that? When kids start asking what if, man, you can't not go with it because they are in it and they're begging to do more math. So when they are asking more questions to solve, or they're coming up with more questions to solve, that's the equivalent of that girl in the middle who was jamming the ice cream in her face. They're begging for you to let them do more math in your class. And that's where we want to go. All right, let's go to the next slide, please. All right, so this is that continuum. Just kind of remember where you kind of placed yourself. As we move up the continuum, as we get to mathematical modeling problems, we're talking about context, right? It's not, here's, like in second grade, you begin to talk about multiplication. Show me a model of 5 times 3. That's not mathematical modeling because there's no context involved. It's not a real world situation. So we've got to get beyond that. And if you're doing mathematical modeling, it has to be a context. Let's go on. So, let's go back. Sorry. So, there you go. Okay, so you kind of know the answer because you just saw it. So I want to tell the story of this continuum. So what does it look like at each stage of this continuum, right? So for procedural mathematics, you already saw the picture. But what does that look like in math class? In K2. Now that's probably not a K2 example, but what might it look like? Procedural mathematics in isolation of context. I can't hear this. Worksheets, yeah, worksheets. Doesn't have to be worksheets, but it could be, yeah. Anything else? Pardon? Memorizing math facts. That's a really, no one's ever said that, yeah. So like flashcards, right? Just do this and remember them, you know? Don't worry about how they're connected. That's not going to help you, even though it really will, right? Yeah, that's procedural. So let's go backwards, or go forwards, I'm sorry. So it could be something like this, or the flashcards, or just working with numbers with no context, right? So how do we take something like this, or like what you said, like some of the other things you said, and let's go backwards if we could. All right, how do we get to that second green arrow? How do we take that math in isolation and make it conceptual math in isolation? I'm sorry? Well, that's. I think you're getting ahead of things, because when you solve a real world problem, there's a context involved. So this is conceptual mathematics in isolation of context. So what can we do to take that worksheet, or the memorizing of facts, or just the naked math problems, and make it conceptual, help kids understand what's going on conceptually? Manipulatives, yeah, that's one way. Sometimes it's even just drawings, right? Helping kids make the connection. What's really happening when I add, like in kindergarten, using 10 frames is huge to help them develop the idea of 10 as a unit. Continuing with that in first grade. So doing those kinds of things helps us get to that second arrow. Now, how do we get to the third and fourth arrows? What's the difference? We might still use manipulatives, right? I would encourage that all the way up this whole continuum. But what do we need? Yeah, that's it. Context is the only thing. We need to use context. So let's take a look. Let's go 2 slides ahead. So how are we going to do that? Now, we've got to help. Remember, somebody said earlier that mathematics was problem solving, right? Who was somebody over here? Nobody wants to take credit for it. Okay, all right. You all get credit for it. Excellent. So how do we help kids become better problem solvers? Remember, I said we have to empower kids. Now, great, Mike. How do we empower kids? Well, these little yellow post-it notey things are kind of like because there's not anywhere up here where I can like hang chart paper where I would normally do this with kids. But imagine this: if I'm in a K2 classroom or a K5 classroom, I would do this with kids because I want to help kids realize that they can do mathematics, they can make sense of mathematics. And this is just one way. This is what I do. You don't have to do this. This is just what I do. It's one of the ways that I do this. So the first question I asked was through one click. And I asked them, since we talked about what is mathematics, now we talk about what is problem solving. Since mathematics is problem solving, now we've got to talk about what is problem solving. Now I want you to think like a K2 kid, K2 student. If I asked a K2 student this, what is problem solving? What would they say? Yo, who said it? You all said it. What is it? Solving a problem. That's exactly what they say. Now they say other things too. It's solving a problem. What else do they say? Finding an answer. Good. Yeah. What else? Getting to the end. Oh, that's a good one. Okay. What else? Doing math. That's a great one. Now, and what grade do you teach? You said doing math? Oh, it was you? Oh, it was you. I thought it was you. She threw her voice, I think. What? Second grade. Okay. So I'm thinking back. I don't know if I've heard it from a second grader, but they like in kindergarten they said that. I know that they said that in kindergarten. For me. What else do they do? What else do they say? Oh, so let's click one more time. This is some other things that I hear. It's addition, it's subtraction. For upper grades, they say multiplication, division. And it's when you solve a problem, which you guys said also. So then I give them a problem based on their definition of problem solving. Right? This is their definition typically. Now for K2, this is what I might say to them. Okay, based on what you said, I'm going to give you a problem based on what you said. Bonnie has 12 markers, and she gave me 3 of them. You all are not acting like a K5 classroom. because at this point, every hand is in the air. Every single hand is in the air. No, I haven't even asked a question yet. Every hand is in the air. Every single hand. Every time I do this. So I call on, I say, don't tell me anything, but answer this question for me. What question are you trying to answer? And then they say, how many markers does Miss Bonnie have left? Okay, all right. Is that the question you all were thinking of? And they say, yes. I say, okay, here's what I want you to do. The count of 3, I want you to whisper shout the answer to me, okay? And I want you to do this because you're K5 students right now, right? So on the count of 3, tell me, remember she had 12 to start, she gave me 3. How many does she have left? Are you ready? 1, 2, 3. Now you did not act like K2 kids. Because you know there's one kid in the class who's just going to shout it out, right? He's not going to whisper. He wants to be heard. It could be a she, but it's usually a he. So yeah, 9. Okay, so my follow-up question, remember the goal here is to help kids realize what problem solving is. So I asked them, you all got 9, right? And even if they didn't, they're nodding yes. Right, because it's what they're gonna do. I say, you all got 9, you all got the correct answer. Was that a problem for any of you? And at this point, again, you're not acting like a group of K2 students, because some of the students, no, that was easy, Mr. W. That was so easy. No, I knew what to do right away. No, it wasn't a problem. I say, you're right, that wasn't a problem. Because that's not what problem solving is. Go ahead and click once, please. That's what problem solving is. I tell them problem solving is what you do when you don't know what to do. And kids kind of laugh at that sometimes because it sounds kind of silly to say something like that. But if you don't know what to do, and you eventually, like initially when you first get the problem, if you don't know what to do, and you keep trying, and then you solve the problem, you've problem solved. But if you know what to do right away, that's not problem solving. So we've got to help kids realize that if you don't know what to do, that's normal. Like when you get a problem and you don't know what to do right away, that's normal. And everybody goes through that. Okay, so the next one we're going to do is what do good problem solvers do? So I ask them, what do you think good problem solvers do? Again, K2 students, what are they going to say? Look for clues. That's a good one. Yeah. What else do good problem solvers do?
Think.
Oh, who said that? Think. Did you look at my slides ahead of time?
No.
Okay. I'll believe you since I don't know.
I just love that.
I'm giving you a hug from here. Okay. All right. So they think. We'll come back to that in a minute. What else do good problem solvers do? Analyze. Ooh, that's a big word for K2. All right. What else do they do? They what? They try. And they keep trying, right? Good. What else do they do? They're flexible in what? Right. So again, it goes back to her try, but they're persevering, right? That's that word that's in our mathematical practice standards. So let's click once. So here's sometimes I hear this more, the first one more from second grade, but they read the problem, they ask questions, they study, they do their homework. This is what they say. They don't give up and they work hard. So we heard some of those worded a little differently there. The reason some of them are blue is because I wanted to make sure I went back and talked about those because those require follow-ups from me. So they say they read the problem. I ask, why? And usually I get back, well, teacher says we're supposed to read it 3 times. So I say, why? Why 3 times? And then, like, all the heads turn to the teacher. Why? And, eventually we have a little conversation, why? What's the purpose of reading the problem? Why are we reading it? And it's the purpose for reading anything, right? Let's click twice. Yeah, so it's to understand and make sense. So comprehension is the whole point of reading anything, whether it's a math problem or, a science text or what. So we eventually get to that point, and then ask questions. Well, who do you ask? And this is a question I ask to anybody that I do this with. Who are you asking? And of course they say, the teacher, right? Well, there's only one of me and there's 20-something of you, so is there anybody else maybe you could ask? We talk about, I could ask my partner. Great, you got another person to ask. Great. And then don't give up. You know, what does that mean? That means we keep trying. If something doesn't work, like you said back there, if something doesn't work, we try something else. And we just keep trying, because if we don't know what to do, that means we've got a really good problem. And we've just got to persevere and keep trying. But then you said think. So let's click one more time. That, sometimes they don't say that. Actually, a lot of times they don't say that. So if they don't say that, then I've got a way to get them to say it. Because they'll usually come up with all these other things first. And I'll say, oh, you know what? There's one more I'm kind of looking for. And you're all doing it right now. And usually somebody comes out with it pretty quickly. And that goes in big, bold, as big as I can make it at the bottom usually, because it comes up last usually. And I usually just put it in the biggest, boldest letters, sometimes highlight around it. Just make sure that everybody knows that good problem solvers think. Because every one of those other things up there requires them to think. And guess what? I'm subtly hinting to them that, oh, I can think. You know, kids are starting to think, oh, I can think. Maybe I'm a good problem solver, right? Okay, so the next one we talk about is, what tools do good problem solvers use? Again, think like a K2 student. What would they say? Or what might they say, I should say. Pictures? Yeah, I might use pictures. What else? Fingers? Yeah. Yeah, you took the hint. They don't usually do that, but that's a good one. We're going to come back to that in just a minute. She said brain. What other tools do you think a K2 student would say? Objects like what? Blocks, counters. Yeah, they name all. They start looking around the room, you know, or they start thinking, what did we use last week? You know, they'll say base 10 frames. They'll start saying counters, like you said, cubes. The bears, you know, they might say, depending on. So this is some of the things that they do say. I don't know if I have bears up there, but they do say counters. Yeah, counters, not rulers in K2, or K1 anyway, but base 10 blocks, you know, they might say tiles or cubes, things like that. Pencil and paper. They do say fingers a lot. And then they also say brain. Okay, so this is really important, because brain goes at the bottom, just like think does, and it's always in big, bold letters. So again, what we're trying to do is we're trying to help kids realize that they can make sense of mathematics, right? Is the brain up there yet? No? Okay, it's coming. Because the next thing I do is, when these go on the wall, because these are anchor charts, I connect the two. Everybody's got a brain. Everybody can think. Guess what? Everybody can be a good problem solver. Every single person. Every single student. Doesn't matter if they're on an IEP. Doesn't matter if there's special needs. They all can do mathematics, and they all can solve problems. So these go up on the wall. Now, is this enough to make sure that every kid is a good problem solver? No, that's the answer. No, it is not. We've just kind of set the stage, because they're still thinking, even though we already said that problem solving is what you do when you don't know what to do. They've had, if they're in second grade, they've had a couple of years where that's kind of what is ingrained in them. If they're in kindergarten, they're at the beginning of that, but even before they got to kindergarten, they probably experienced situations, maybe at their home, where math is more procedural, and it's just about getting an answer. So we've got a lot of work to do, no matter what grade we're working in. So the next thing I do is I present them with a problem that's way different than what they're thinking. And it's a problem where, guess what? They're not going to know what to do right away. And guess what? They're going to struggle a little bit. But I have a way to help them get through that struggle. So let's go to the next one. And can you go to the next slide just real quick? Okay, go back now, please. And thank you. So, Bonnie, can we get one one little chart paper up here, and can you help me? I'm sorry, or someone, just to help, because there's something I thought was there and it's not. And please and thank you. So this is something that, this is a K2 problem. And I've done this several times with several different groups of teachers, well, kids too, but several different groups of teachers. Yeah, anywhere is good. And thank you. Yeah. So those charts that we did, again, they're on the wall and they can always refer back to them. But the goal is we've really got to help kids make sense. So I want you to read this really quickly. Just kind of run through it. Now with students, in kindergarten it would be a lot different because we'd be reading it together and we'd be talking about it afterward. In first grade, we might do, depending on the time of year, we might do something similar. By the time we're in second grade, we'd be reading it, maybe reading it individually, and then we'd read it together to try and make sense of it. But even that, and a lot of times, like in second grade, I'd say, okay, I've got this, and I got it on strips of paper, just written on strips of paper. They can take it, put it in their notebook, or put it in their journal, whatever procedure is in the classroom. I say, I want you to start reading it, and make sure you can try to make sense of it. And if you don't make sense, if you can't make sense of it, that's okay. We're going to get to that. We're going to help you with that. But start reading it as I pass it around, and just give kids a minute to do this. So it's not presented to kids in this way. But then we've got to help them. We've got to help them figure out and make sense of the problem. Because that's a lot of words, right? That's a lot of words for me to read. It's a lot of words for K2, so we've got to help them make sense of it. So we make what I call a wick and wink chart. Can you remember what we did that last time? The wick and wink? two column chart table, W-I-K and W-I-N-K. W-I-K, yep. And then the other side is wink, W-I-N-K. Yeah, all right, and that's a 2-column table. And the wick and wink chart, I wish I could take credit for this, but I got this from a 3rd grade class that I was working with. I don't know where she came up with this, but the kids, she decided to do this with her kids, and it started off as a what I know and what I need to know chart. But when the kids started making this in their journals and their notebooks, they didn't want to write what I know and what I need to know on their chart because it took up too much room. So they abbreviated it and they started calling it a wick and wink chart. And I thought it was brilliant. And I wish I'd thought of it because then I would have retired, written a book about it. And but that's okay. It's all good. So after we read it, we're not going to read it out loud here. But after you've read it, you've all had a chance to kind of read through this. What's something you know about this problem? A fact, something you can tell me that you read, that you know that might help us solve the problem. It's what? That can only have 10 feet. 10 feet total, right? Okay. All right. What else do we know? There's what? People and pets are allowed in this apartment, yes. That's really important. It's what? So you're thinking ahead, you're strategizing already. Good for you. Good for you. So hold that thought though, okay? So we had 10 feet living in the apartment, and then it can be people and pets, we said. And then you said that we think there's more than one answer. And we can put that up there too. We think there's more than one answer. I love how you just, you're so inclusive there. People generally have 2 feet. Yes, there are lots of options. And with different grade levels and different classes, we can talk about how, different numbers of feet for different types of animals, just so kids have and we can put that on a separate space. And I think that's really helpful, for sure. And most people have 2 feet, yes, yeah. Any other things that you see up there that you think we could pull out? Thank you for, you know what? I am so, thank you all for jumping out and putting yourself out there, because that is something, every time I've done this with teachers, with kids, that never comes up. But every time I've done this with teachers, you guys read 10 feet apartment and you think, oh, that's got to be measurement. But I wouldn't be doing this with K2, well, K1 anyway. I wouldn't be doing this with K1 if we're talking about feet as a measurement. So when kids see this, even second graders, they think, oh, 10 feet apartment, that's got to be these, right? And it's never an issue. But I'm so glad you put yourself, thank you for being brave and putting yourself out there. Yay, yes, and you as well who did this, yes. So I appreciate you doing that. There's so that's what we know. What do we need to know? What do we need to find out? So, right. So that's what we said. Something like that was said over here. That usually 2 feet on a person, and then we could make maybe over here on the board we could start talking. Well, people have 2, and we could just draw stick figures of dogs and cats, and just talk about the number of feet. Just so it makes it easier for kids to kind of attend to the problem. But what are we trying to find out here? What's the goal of solving this problem? All the ways that we can have 10 feet in an apartment, right? And we can use people and pets. All the ways to make 10 using people and pets. 10 feet using people and pets. Okay, now it does give some suggestions there, or some directions there at the bottom, to find the different combinations of people and pets that could live in the apartments, and then draw pictures and write or tell about these families, right? And that's the goal. So think about what we've talked about just in the last 20 minutes. We've made 3 anchor charts to talk about what good problem solvers do. So you all know what good problem solvers do. And if you can't remember, it's on the anchor charts. So we can run through them again if we have to. You know what tools good problem solvers use because you listed them on the anchor charts. And you know that problem solving is what you do when you don't know what to do. So even after doing this, there might be some students who are struggling to figure out, what do I need to do? And that's okay. But more kids now are probably ready to solve it because we've reduced this to that. It's not circling the important information, because we can do that, but then we've still got all these other words up here that we've got to kind of sort through, even though we circle it. We've just made a bulleted list out of a couple of paragraphs. And that's way easier to digest for kids. For adults, I don't know about you, I'd rather read, if I've got to read, a 5-page paper and it can be reduced to 5 bullets, I'm reading the bullets. I'll go back and read the whole thing, but if I can get the bullet points, I got a better sense of what's going on. So what I want you to do is, in just a second, don't get up yet, we've got some chart paper over here for each of you, well, not each of you, for groups of you to work together, about 6 per group, maybe 5 or 6 per group. There's 2 groups per table, is that right? Yeah, 2 groups per table. There's markers, there's chart paper over there. I want you, now that you know what to do, and you've got the wick and wink chart you can refer back to, and this is the problem, I want you to come up with some solutions, because you did say you think there's more than one. So if you can think of more than one solution to this, please jot that down on the paper. do some drawings and either write or tell about your solution. Be creative. Math is a creative subject. Don't go too wild, okay? But I do want you to have a little bit of fun with this. We're going to do this for about, let's take about 15 minutes, and then we'll continue from there. Sound good? You all know what to do? Okay, so you can head on over there, and we'll see you back in a minute. Bet. because that was like exactly 5 minutes. You guys did great. So first of all, let me thank you for engaging in that quick little problem-solving activity. I heard, first of all, I saw a lot of things that I love to see when students are solving problems like this. I saw a lot of smiling, a lot of talking, even some laughter about some of the things you were thinking of, because you were allowed to be so creative. Also heard a lot of good conversations about what could be done. And I want to give you a chance to share those in just a minute, or how you could change this to work with your own students. So again, initially with students, they may be stuck, but after, especially having time to talk and ask questions to their partners on this, they usually do really well. May take them a little while to get started, but they usually jump right in and get something done. So just some initial reflections on what you just did. Just anything that you want to share. It was fun. Oh yeah, so that's good. It's always a plus when it's enjoyable, right? What else?
Had a different representation of the animals in different combinations. Like, I don't think there were
Yeah, I don't think there are two that were exactly the same. There were some similarities. Like some people had some similar, I think there were a couple of groups that had 5 people, but then they kind of varied from there. Any others? Snails do have 1 foot. Just that thing that they crawl on is a foot. So I didn't mean to crush you when I said that. I just, yeah, their spider had to lose a leg after that. So, but that was, yeah, even learning that, she ended up really well, this is a horrible way to say it, decomposing that one spider leg into a snail foot, and it was, yeah, I think it'll live a productive life for sure. I'm sorry? He still got 7 legs. I mean, shoot, we could probably take 2 more off, he could still be fine. Anything else? Any other thoughts? Yeah, isn't it? It's always nice to be creative, giving some freedom to explore and think. Like we constantly hear, think outside the box. Well, if we're training kids to follow procedures, they're never going to learn to think outside the box. We've got to allow them to think outside the box when they solve problems, like this, or similar problems. Thank you for sharing that. It's a great point. Okay, so what was the mathematical goal here? Oh, you know what? Hold that thought. Don't answer that yet. Because I want to ask you this first. What were some mathematical ideas that you discussed? Because I bet it was more than just one. Oh, we got repeated addition here. I saw a couple of examples of that, and I could tell which groups were mostly 2nd grade just by looking at them, because a lot of them had ×2 on them. Yeah. So so repeated addition. What else? What other ideas did you talk about? Making 10. Yeah, because that was. We stated that right in the beginning, right? So that was something that I'm sure you talked about. We had to make sure things were 10. I saw some people counting over and over again, or adding a couple of different things. Oh, we need 2 more legs, or we need 2 more feet. So you were thinking the whole way through. Anything else? Oh yeah. So skip counting was probably a part of some of yours, especially if you used a lot of people or birds, right? Even in odd numbers, that could come up for sure. Especially, there was one group in the back here that had started out with a 3-legged dog, and then they realized, oh my gosh, we need another odd numbered leg thing. And or what? Or a snail. I don't think they came up with the snail. Are you going to let that go, or is that going to follow me all the rest of the day? Okay. I'm so sorry. I mentioned it just just to be precise. I just wanted you to be precise. What else? Yeah, I'm fishing for something because some of you did some things that, actually a lot of you did it. Let me give you a hint. And I only chose this because it was the largest one. Yeah, so in this, by solving this and allowing some of that creativity, you get to have kids discuss zero in a context. Zero actually means something here, right? So kids are using the idea of zero to solve a problem, and then like some of you, who was the group that said infinity snakes? Oh yeah, okay, yeah. Now I wouldn't expect that from K2 students, but that's a big idea. And kids will say, oh my gosh, we could have 5 people and 1 snake, and 5 people and 1 fish, and 5 people and a snake and a fish. And they're using that idea of zero to make sense of the quantity of zero in the context of solving this problem. Now, it's okay if students don't use a snake or a fish. That's fine, that's fine, they don't have to. But it's really interesting to have those conversations with students. Wow, how come you can add so many snakes? Because they don't have any feet. Well, how do you know that makes 10 still? Because if I add no more feet, then it's still going to be the same. And they start to really get a deeper understanding of what zero means. And that's probably one of my favorite reasons for using this this context or something like it, because of that deep development of the idea of zero in the context of adding. So there's a lot more here than just adding to 10, right? You develop that idea of zero. It's a problem solving. Kids are getting creative, and that creativity leads to some of that deeper understanding. And Maureen, can we go to the next slide for just a minute? So, actually, go back one more. I'm sorry. So let me ask you this. Remember that continuum, the green arrows? Do you think this problem is more of a math and context like that third arrow? Or do you think this is mathematical modeling? Talk to your Elbow partners. What do you think? Is it more like just a math and context problem? Or is it mathematical modeling? Just talk for about 90 seconds.
There's one piece, but then they're also like coming through it and then putting it together some of it.
It's choice, right? Okay. What do you think? Let's do it this way. How many of you think are leaning more toward mathematical modeling, the top of the thing? Okay, good. How many of you are thinking more the third arrow, like it's conceptual mathematics in context? And how many of you have no idea what you think? It's okay. I mean, that's why we're here. You're trying to figure these things out. So can I hear from someone who, let's start at 3. So if you're at that third arrow, like you think it's conceptual mathematics in context, but you don't quite think it's mathematical modeling, can we hear from somebody? I think some of you were around here and over here. You guys were like this, right? Was that you that was going like this? What do you think? Right. Okay. So you weren't really sure, but you're kind of leaning more toward the third one? Okay. All right, that's fine. Any other thoughts on if you think it's in that conceptual mathematics in context? All right. How about all of you people that said you think it's definitely in the mathematical modeling one? What do you guys think? And then there were crickets. And nobody used crickets on their thing. Oh well. Somebody used a ladybug though. Who were you? Oh yay, woohoo, ladybug. I'd never seen that before. That was really clever. Okay, so mathematics. Somebody's got to answer because this thing's about to blow. What did you guys say? Because you said mathematical modeling, right? So it's definitely, I think we're definitely leaning more toward the engagement part, for sure. So, because you guys were even engaged, and it was pretty easy for you. I don't think the math was too hard for you guys. But what did you say earlier when I came down? What did you say? You said something when I came down there. That's right. Okay, that's what it was. Yes. So they had a lot of choices. And remember, we talked about mathematical modeling. That's one of the things, one of the requirements where kids have choice. So in that respect, I think it's leaning toward mathematical modeling. But I got to go back to what you said, right? I don't think there's a landlord out there that would have an apartment building like this. So, but it does deal with an apartment building context, which is a real thing. But there's even more, I think. Yeah, so, and you're actually getting to more about what mathematical modeling is, which is when we model with mathematics, anyone, students, adults, whoever, whenever we model with mathematics, the model actually begins here. It's not necessarily what we put on the paper. That's a representation of our model. But the modeling actually begins in our brains. So, but there's even more. If we could go back to the problem, I want to point out a couple of different things. So, in a mathematical modeling problem, first of all, the context should be authentic, right? And we're kind of on the fence on that. We're not really sure about it. They did have a lot of choice, or you guys did have a lot of choice to solve it. So, in that respect, it kind of feels like a mathematical modeling problem. But there's something here that makes me push it down to that third arrow. And that thing is, everything they need to solve the problem is right here. Everything. They don't have to make any assumptions about anything. Really, they can make a lot of choices, but they don't have to make any assumptions. Like they know, how many, maybe not a snail, but they know how many feet a dog has. And if they don't, we can certainly, like I said, scaffold that understanding before they get started. But so they have everything they need to solve the problem. In mathematical modeling, they don't. Everything isn't provided for them. So for me, this is more on that third arrow. Okay? And I think most people would probably agree just because of what I just said. If you're doing real mathematical modeling, assumptions have to be made. Whether those assumptions are made consciously or not, there's assumptions being made. So let's go to the next one. So that's great. So we've talked about that first arrow, that math in isolation, so the naked math problems. We talked about making that conceptual, right? We let them use manipulatives and drawings and help build the conceptual understanding. And then we just talked about how to get into that third arrow with problems like this. So what's mathematical modeling? Let's go back to that picture we saw before. Remember, I didn't say yay or nay. So let me run through these. I'm going to say some of the things that you already said and some things that maybe help you get a clearer understanding about what mathematical modeling is. First thing, every one of these companies uses mathematical modeling, every single one. A lot of them use it by collecting data. I think someone said that earlier. So the Coke machine, we've probably all seen these things around, right? There's like hundreds of drinks you can get from this one machine. And sometimes when you're waiting in line to use it, it's tedious to watch people go back and forth. And I just think there's got to be a better way. So somebody needs to come up with a better model for this thing. But the idea is to get this to work, the inner workings of this requires a lot of mathematical modeling. Like, how do you know, when you press this button, how does it go to that? How many different combinations are there? There's a lot of things in here that build up to this. And on top of that, Coca-Cola has to determine what flavors are they going to put in there. And how do they determine what flavors they put in? Are the flavors, the flavorings like cherry and vanilla and orange, are they the same here in Atlanta as they are in, I don't know, Chicago? Or do they like different flavors up there? Right? So they've got to use mathematical modeling to determine that, to create the machines and set them up so that they get the correct flavors. Amazon, anybody use Amazon the last couple months? Yeah, oh, now I get the hands. Nice. Now you're engaged, right? Okay, so yeah, a couple months ago, I was about ready to purchase something for my wife for Christmas. And I knew what I wanted. I found it on Amazon, about ready to have it shipped. But then, when you click on something, before you say checkout or before you say put it in my bag or whatever, you scroll down and what do you see? Yeah, people who bought this also bought, and then there's this list. It's not like 2 or 3 things. You can scroll on that thing too. There's like 12 things there or more. Now, how do they come up with that list? They use mathematical modeling. They collect the data from all the people that have put this in their basket, and they use some kind of mathematics on it, and they say, oh, okay. And they probably know, because it's my account, they probably know I'm a male, so they probably have different things for me than they have for a woman who might pick the same thing. So we're being manipulated all the time with all these things. So they're using mathematical modeling every time you get on Amazon. I promise you're getting data collected on you. And they're using it. And they say it's to better serve you, but when everything on Amazon has 4 stars or more, I begin to wonder, a little bit about that. Doritos, someone mentioned something about Doritos. And you notice the little yellow circles next to each bag? I purposefully covered those numbers up. Because human beings, we like things to be nice and nice patterns, right? So when we look at this, there's 20 bags in this variety pack. We want there to be 5 of each of those 4. Guess what? There's not. But for a reason. Because Frito-Lay also collects data. And they say, they ask people, of these 4 types of chips, which one do you like the most? Rate them in order 1 to 4, 1 being the most, or 4 being the one you like the most. And they collect that data and they make the variety packs based on the data they collect. So this one, I believe, like Cool Ranch was like 7, and the rest were like the puffy Cheetos, the not crunchy ones. That's like 3, and the other are 6 and 4. So they're making them tailored to where they're selling these variety packs. Now, what's really interesting is the variety packs here in Georgia are different from the variety packs in the Northeast, because they like different kinds of chips up there. So they collect data. Now, what's really cool is you could do this with your kids. You could say, of these 4 chips, which ones do you like the most? Once you collect the data, make a variety pack. How many of each one would you put in based on the data that we collected? They're creating a variety pack of their own. And then you can compare it to the one they sell in the store and see how close they were. That's mathematical modeling, because they've got to assume that their data is similar to what Frito-Lay used. Now, as you go up in the grade levels, you can do a lot more with this, but that's a really neat mathematical modeling problem involving data. Now, eHarmony. And now I'm about to tell you something about eHarmony. First of all, I am not a customer, right? Happily married almost 25 years, never used eHarmony. I just know about the company. So they have like 48 compatibility statements or whatever that they use. And if you ever go on eHarmony, you sign up, they give you those statements, and it's a Likert scale, so it's 1 to 5. 1 being, this doesn't describe me at all. 5 being, that is me. That describes me perfectly. They collect your data. They do some kind of mathematics on it, some mathematical model. They come up with this number. That number is matched with people with other numbers similar to you in some of those same categories. What you don't know is that in eHarmony, if you score yourself on those compatibility measures, if you score yourself a 5, like the extremes, like a 5 or a 1 on any of them, they eliminate them from your profile. Any idea why they might do that? What? Yeah, they're saving you from yourself, right? They want you to find love, right? And they realize that when the extremes, they don't get matched up a lot, right? So they're saving you from yourself. They're taking your data and they're helping you find the love of your life by eliminating those extremes. Now, if you put 5s on everything or 1s on everything, God bless you. I don't know what they do with that data. I wish you well in that. But and again, for students having conversations like this, I would never use eHarmony. That's just for you all. Little fun stuff. Let's go to the next one. So we've talked about everything that mathematical modeling isn't so far. So let me give you a suggestion. This is just a scenario that could be used in K2. This is one that I've described quite a bit. And it involves these small sleeves of crackers. Ritz crackers, just a few years ago, just started making these smaller sleeves. Brilliant idea. I don't know why they didn't do this sooner. Great idea. Because they just go stale otherwise, right? Is that what you were saying? Back there. They do in my house. I don't know if it's everywhere, but in my house. So, so consider this scenario. This could be in a K2 classroom easily. So you bring in a box of these sleeves. I think there's like 8 sleeves, depending on the size of the box. 8 sleeves of crackers in a box. And you could bring it in, or a parent could bring it in, or just be donated to your class. And you sit the kids down, you bring them to the carpet, or you could just get them in a circle, however you want to do it. And you say to them, we just got these donated to our class for our snack. We can have it later this week. What questions do you have? Now that's a wide open question for K2, I get it. So what are they going to say? When are we going to have it? Can we have them today? Even though we said we're having them later this week, they're going to say it, right? So that's okay. It's all right. I know it's coming. We're gonna have that conversation anyway. We'll have it later this week. But eventually somebody's going to say, what? How many can we get? Some kids might even say, or maybe one kid, some kids might even say, can we each have one of those? Right? Can you hear that from some of your kids right now? Some of you nodding? Yeah, they might say that. And if it's like a kindergarten class and they say that, which is highly likely, you dump out the box and you choral count them, right? You go 1, 2, 3, counting together, 5, 6, 7, 8. There's 8. Is that going to work? Can we all have one of those? Have a little talk about it? Nope, that's not going to work. Okay, so then we can give every group of kids a sleeve. And how would you share this sleeve with your group? 4 kids in a group. They got this nice sleeve of crackers. Now, what's really cool here, because I've been talking about how kids need to make assumptions, it's about to happen, okay? Because these sleeves don't all have the same number of crackers in them. Are kids going to assume that they do? Yes, I assumed that they did. This picture right here, I think I counted 13, which is another great number because it's not easily dividable. Remember I talked about the real world is messy? Here's an example. Now they don't all have 13. Some have 12, some have 11, because they're filled by weight. So that's kind of cool, right? So they're going to assume, and they get it. Now this group, let's say you've got a sleeve and it's got 13 in it. There's 5 of you. How are you going to share it? You're going to draw pictures. You might have little counters to use as crackers to represent the crackers. This group here, you might have 11 in your group. You might have 4 of you. How are you going to share those? As kids are solving this and they're drawing their little pictures and making sense, trying to make sense of it, you can be asking questions like, well, you've got 13 crackers, there's 4 of you, and you might say, well, we're each getting 3, and there's 1 left over. So what are you going to do with that leftover cracker? Now, what are they going to say? You're going to eat, well, well, we didn't want it, so we're just going to give it to her because she wants it, right? And that's certainly an option, I guess. What else might they say? Share it. They might share it, but maybe they don't know how. We want to share it, but we don't know how. Or maybe we'd figured out a way to share it. There might be a group to do that. A lot of times kids will say, we're just going to give it to the teacher. Oh, great. That's just what I wanted. Yeah, all right, fantastic. But that's one way, one solution. So how they determine how they're going to share that extra cracker or extra crackers is part of their model. It's part of their reasoning about solving this problem. So how do you share it? You know, how do we deal with that? And you guys might say, I'm just going to give it to the teacher or the principal or whatever. And you guys might say, we're going to break it in half. And then we're going to break those in half. And we might not know the fraction for that, but we're going to share it, right? Fair shares, we can do that. Not all kids are ready for that, but some kids might be ready to do that. That's their model. And when you start putting those models together to talk about how to share with the whole class, then those assumptions get challenged. And that's when they really have to start thinking and reasoning about the numbers involved. And that's just one example of mathematical modeling. There's lots out there. Now, I know what you're thinking. That's great, Mike, we got one. What do we do with the rest of the year, right? There's other ones out there. So remember I told you about the design, the instructional design of the units, where it's engage, explore, apply, reflect. If within the units, you'll see a lot of contextual problems. Some of them will be mathematical modeling problems. And they'll always be in the apply section, every single time. You won't find mathematical modeling anywhere else, except for the apply section. I take that back. In the interdisciplinary units, you'll see mathematical modeling as well. So those two places are great sources. There are other places. Really, the best mathematical modeling problems are problems like this, though, where you present a situation and have kids come up with the question. Have you done 3-act tasks before? Or some of you? If you are doing 3-act tasks, you're kind of already dipping your toe a little bit in the water of mathematical modeling. Graham Fletcher, you've done some things of his. He and I were talking not too long ago about what his 3-act tasks and which ones would be considered a really good mathematical modeling task. And there's one of his, and it's called a rainbow of colors. It's a Skittles one, where he fills the jar with little bags of Skittles, because the kids assume that every bag of Skittles has the same number in it, and they don't. And so that's probably, he said that's probably all of his that he's made, that's the best one for mathematical modeling. So if you want to dip your toe in the water of mathematical modeling and you're like a 2nd grade or 3rd grade, that's a great one to do. What else did I want to say? Oh, also consider this. What are some things that you, like when you're planning something, whether it's a lesson for your kids, or you're planning a celebration, or planning an event for your kids, you've got to do some math for that, right? Why not involve your students in some of that? Grade appropriate, of course. You know, like planning a field trip. How many buses do we need? You know, or that really freaks me out. So how many buses do we need? You know, how much is it going to cost? How many permission slips do we need to send out? You know, all these different kinds of things that we have to do, that we're doing in the background, could be set out in the foreground, and that gets them really a little bit more excited about the event or the field trip or something else. So consider those as well as you're planning and thinking about engaging your kids in mathematical modeling. Let's go to the next one. All right, so these are my tips to help you get started with mathematical modeling in your classrooms. And there's 5 of these, so just do one at a time here, or 2 at a time, yeah. So, however you want to do it. We'll do modeling in real life. So remember, I've said this, it's messy. There's no answer key for a lot of these problems. Like with the crackers problem, there's no answer key. It depends on how many crackers are in the box, which we don't really know until we open it and count all of the sleeves. So it's messy, and you just got to be prepared for that. The second one is we want students, like you guys said over here, students have to make genuine choices. Like even though what we did earlier wasn't mathematical modeling, you had a lot of choice in how you wanted to proceed. With the cracker problem, they have choices about how many each person should get and how to share that last cracker. There's some choices they can make. The next one is just start. You know, try something. And don't think you have to do mathematical modeling problems every day. All right? Sometimes mathematical modeling problems can last, you know, a week or more, where you're doing it maybe a little bit each day, or you're doing, you do it on certain days of the week for 2 weeks or something like that, just to keep it going and keep kids thinking about it. but just start something. Even if you just say, you know, I'm going to try a modeling problem or a 3-act task just to kind of see what it feels like with my kids. But just try something. The fourth one is, if you're going to assess, because this is a big thing, right? We've got to assess our kids, make sure they're understanding things. If you're going to assess a mathematical modeling problem that your kids solve, assess the process, assess that framework, the cycle. Give them feedback, tell them what they've done well and what they need to work on the next time they do a mathematical modeling problem. Because if we want kids to become better problem solvers, better mathematical modelers, we have to give them feedback so that they know what they're doing well and what they need help on. And the other thing is, if you're going to assess, you can assess in 2 different ways. You can assess the process, and if you want to assess the computation or whatever they're doing in the background of that problem to solve it, you can assess that separately. Just don't put a grade on the modeling process, whatever they turn in. Just kind of give them a grade on something else. All right, and the last one is modeling. It doesn't happen in isolation. Modeling is, and mathematics in general, is a team sport. All of us are smarter than one of us, right? Every single person in here individually is smart, but we're all smarter together because we can all learn from each other. Okay, and that's pretty much it. That's all I got for now, and I know you're all probably hungry for lunch because I see some people like shaking their legs. When's he gonna finish? Let's get out of here. So I think we got one more. I don't know if my contact information, oh no, so here we go. So remember the PL opportunities, GaDOE.org/mathematics. That's where all the resources are, and the PL. And let's keep going. And I think, yeah, so this is us. This is where the math team is. My email's up there. If you have any questions, please contact me. Happy to answer your questions, especially if they're about the new standards or mathematical modeling. Those are my passions right now. So do you want to? Oh yeah, do you have any questions right now? Other than where are we going for lunch? Okay, that's fine. Yeah, I think they'll have them when we get back. I think they need food. So I'll hand it back to Bonnie. Here you go.
I have one question, but I was afraid to ask it, is about assessments. Does anybody have any concerns about assessments? What do y'all care, right? It's K2, right? I was just curious about, I guess the expectations or where you see assessment for K2 as we're planning like benchmark type things, developing those.
So currently, like with our standards right now, kindergarten, you have G-Kids, right? That's being completely redone. It should be done pretty soon. Like they should be releasing it pretty soon because you guys need it for the next year, for our fall 2023. So just kind of be on the lookout for that. So it's been revised. Everything's been aligned to the new standards. And I haven't heard from assessment in a few months, so they haven't had any questions for me. So I obviously answered all the questions they had last time, which was probably in November. So just know that that's coming. First and second grade, you have Keenville. You know, familiar with Keenville? Oh, you should be. Keenville is a game-based assessment. So it's like a video game where kids get on and they play these games. They're all aligned to the standards. You get it through SLDS. And it should be already on your thing. If you don't see it, then that's something in your district with technology. So Keenville, Keenville, Keenville. So what kids do is they log in, they play these games, and they're like video games, and they're being assessed while they play the games. They don't even know they're being assessed. They're just playing the game, and then you get a report on your dashboard that tells what your kids are how your kids are doing on the standards. Now, and that's currently, right now, like you can do that with our current standards. They're being revised to align with our new standards as well. So that is something, if you're not familiar with that, and every teacher that I've talked to that's using it loves it. And the kids love it, and they can play the games, they can earn beans. For every game they play, they earn beans. And they can use the beans to buy things for their little Keen house, and they got all kinds of crazy stuff going on. And when the seasons change on the screen, like when it's wintertime, it snows. It's really cool. I mean, they've really done a great job. And honestly, I wish we could have Keenville for K5, or K8. Shoot, K12. Just play a game, and we'll assess you while you're playing the game. Yes. What was her name? Lisa Hardman was, and I think she's still there. So Lisa Hardman, Hardman, in assessment can help you with that. Oh, you know her? Oh, well, there you go. See? Yeah, she's great. I haven't talked to her in a little while, but she can get you started. So, yeah, if you're not familiar with Keenville, I would definitely reach out to Lisa, and then if you don't see it in SLDS on your screen, you should see Keenville. If you don't, then that's something with your county that you need to straighten out. Any questions about that? Yeah. Yeah, that's a great question for assessment. I don't know. I'm sorry, I don't know the answer to that. I wish I did. Because the only assessments that I deal with are milestones for 3-5, G-Kids for kindergarten, and Keenville for first and second. Yeah, that's and usually when we find those, that's something that's addressed right away. And I haven't been as involved with Keenville this year because of the new standards. I've just been traveling too much. But anytime you see something like that, please contact Lisa Hardman, because she will be on it. And if she doesn't do it, she can point you in the right direction to get it fixed right away, because we don't want those out there. Okay. And I'm glad you said something, because they send the games to me first to play the games, to try and break them. And so it's always at the end of the day when I don't want to do anything else, and I play those games, and my daughter would walk in and say, "What are you doing?" Because she hears all the beeps and boops on there. And I'm working. She said, "Looks like you're playing like a game for a first grader." I'm like, "Well, I kind of am. Yeah, it's part of my job." She's like, "I want your job." I don't know if you do really. That's one of the perks. Any other questions? All right, I will be here after lunch, and so if you have any, as you're at lunch and you're thinking about stuff, you can ask me then.
And yes, I wanted to mention that too. Mike is with us, and he will be circulating between the different grade levels. So when you have questions, if you want to put it on the parking lot, we'll make sure that we address it, or he's approachable. He's not too scary. But what I want to do before we break for lunch is go ahead and get into our groups. That way, when you come back from lunch, you're ready to work. Kindergarten will be down here, over here where the tables are. So if you are kindergarten and you want to go ahead and take a chair, take one from this side first and just put them under the tables. That would be great. And then first and second will be upstairs. The first grade, Anita, you're where? Okay, so that's where first grade will be, and then second grade will be in the game room. Okay? So, well, there's ping pong, there's Connect Four, there's all kinds of games up there. So we'll go ahead and get established, and then a lunch